Hey guys, in my previous videos I did the derivatives of logarithms, of natural logarithms to be precise, something like ln of the argument, something like ln of 3x plus 5, ln of 5x. Also I did cover it more complicated example, something like ln of square root, and you are also given something like 3x plus 1 inside expression. So basically what I did before, I did use the chain rule since you are given a composite function. Basically your function is made of, first of all, the ln function, the natural logarithm. You have another functions that nested inside. So namely you have square root and you have something like linear function inside. So basically I did apply the chain rule twice. Now I would like to show you another way of taking the derivatives of these functions by using the laws of logarithms. So the idea is, before taking the derivative of this ln function, use laws or properties, if you will, of logarithms to simplify your log expression first, and afterwards take the derivative. I'm going to cover these types when you are given ln and your argument of your ln function, something like square root, or also it could be extended to any root, any radical, and you have some expression inside your square root. Again, it could be any expression, not a linear necessary. Second type, I wanna cover the reciprocal, so something like 1 over another expression which is on bottom of your fraction, and it's the argument of your ln, something like inside. And finally I will walk you through when the argument of your ln, something like power outside, and you have two expressions being multiplied as a argument inside of this power. So let's get into this. Say you have been given something like ln of square root 3x plus 1, and you need to find the derivative of this function, or you need to differentiate it with respect to x. And before we get started, a little bit remark. If you don't want to use these laws of logarithms, if you don't have to use it, so you could simply ignore me at this point. And if you need to know straightforward solution, just jump to my previous videos when I did this kind of examples without applying laws of logarithms. Straight away, straight up. Feel free to check it out. But to be perfectly frank with you, if you use the laws of logarithms, their way of taking the derivatives of these functions would be much faster, would be much rapid and much quicker, and you will see. So basically you could jump to this video and compare to what I'm going to do now and what I did before, in order to see how faster this way will be. First of all, to be on the same page with me, you need to know the basic gist of the chain rule. And I do have a bunch of videos on the chain rule, and if you need this extra help, I will link all these videos down below, and go ahead and check them out. Also, you need to know the laws of logarithms, and also sometimes they're called just properties of logarithms. Also, I do have a separate bunch of videos on laws of logarithms. Also, I will link these related videos down below in the description box. And all of this stuff I'm going to use in this video. Now, you have been given a ln of square root of 3x plus 1. So definitely you are given a composite function. So you need to identify that your outside function is ln, first of all. And you have something that inside in your function. You have, first of all, square root, which is inside. And inside square root, you have 3x plus 1. So your square root basically is made of the linear expression, linear function 3x plus 1, if it makes sense. Now, you need to spot which laws of logarithms you should use, you should apply. And first of all, I'm going to rewrite this root as a half power, since I don't want this root. I want to just get rid of this root. So go ahead and rewrite it as a half power. So you want to keep this ln. You have this 3x plus 1 inside, and you have a half power instead of square root. So you still want to keep this argument 3x plus 1, which is inside of your root. So 3x plus 1. Now, this is the moment where the laws of logarithms kick in, particularly the power law of logarithms. And basically, as a quick reminder, the power law says if the argument of your logarithms raised to power, let's say, p, or in this case it's going to be a half, this power can be taken out front as a coefficient. So this power basically comes out in front. So go ahead and rewrite it as a half, as a coefficient, times, and you have still this ln of 3x plus 1. That's your function. So again, that's the power law. Check to see if you can simplify any further, and at this point you cannot. So since this function precisely the same is equivalent to this function, so you can take the derivative of this. And believe me, the derivative of this function, to take the derivative of this function, would be much faster and easier if you start off by taking the derivative of the original one. So y prime, let's call this function just y for the sake of simplicity. So y prime, the derivative. So you have a number, a constant being multiplied by the natural logarithm of something. So the derivative of this function is going to be, so first of all you want to keep this constant a half. And you want to take care of the derivative of ln. So recall that the derivative of the natural logarithm is 1 over that entire argument, which is 3x plus 1. So it goes on bottom of this fraction. And we are not done yet. Always keep in mind the chain rule, since ln is made of 3x plus 1. It's not ln of x, it's ln of something more complicated, more complex than x. So you have to apply the chain rule at this point. And chain rule basically said that you have to take the derivative of 3x plus 1. The derivative of 3x plus 1 is going to be just 3. Since the derivative of 1 is just constant, is 0, derivative of any constant is just 0. And the derivative of x is just 1, so you're left with 3. Alright, and technically we are done with the derivative, but you have to simplify this expression since we don't want to leave this house like this. 3 goes on top and 2 remains on bottom of this fraction. Go ahead and rewrite it. 3 over 2 3x plus 1 remains on bottom, and that's your derivative. Yeah, that's your derivative for this function. And again, if you don't have to, or if you don't want to use the laws of logarithms, if you start by taking the derivative straightforward, so first of all, as a quick kind of a guide, if you will, first of all, you want to take the derivative of ln, and it's going to be 1 over this root. After, you have to apply the chain rule. You have to take the derivative of square root, and you have to take the derivative of 3x plus 1. Well, again, feel free, go ahead and check. So anyway, anyhow, you end up with the same answer, with the same derivative. Alright, say you have something like ln 1 over something, some x expression, let's say 5x plus 2, and you need to differentiate this function with respect to x or find the derivative. Again, you can find the derivative of this function by applying the chain rule multiple times, but I want to show how to find the derivative of this function differently by using the laws or the properties of logarithms. First of all, look at your argument. You have 1 over something, and recall the basic power laws, basic power properties. If you have something, let's say 1 over x, it's the same thing as x raised to the negative power. So basically, the negative power indicates this reciprocation, so it's 1 over. Before taking the derivative, go ahead and rewrite the argument as a negative power, and after apply power law of logarithms. So it will equal, so you want to keep ln at this point, and your argument becomes, so you want to take this entire bottom, so it's going to be 5x plus 2, the argument of your function. I'm going to use the square parenthesis for this entire argument. And what you have inside is going to be just 5x plus 2. This entire argument to the negative 1 power. It's precisely the same thing. Now use what we did before in the first example. You have argument of your log raised to a power. Doesn't matter which power you have. It could be also negative power. So use power law of logarithms, which basically tells you that you can take this power and bring it in front of your logarithm as a coefficient. So basically this power comes out front. So it becomes negative 1 technically, but I'm going to just neglect this one. Doesn't matter at this point. So you still have this ln, and your argument 5x plus 2, it remains the same. And we are done with simplification. Look at your original one. It looks spooky, it looks intimidating, and at some point you get lost. You don't know what to do, how to start off. Look at this one. You have just negative ln of something, which is much simpler than original one. And at this point, go ahead and take the derivative. And by the way, I do have 2 separate videos on taking the derivatives of ln, something like this. So if you need these extra examples and extra help with this, go ahead, jump to these videos. All of them I will link down below in the description box. So y prime, the derivative of this function equals. So look at this function. First of all, you want to keep this negative since your entire function becomes negative. So you want to keep this negative sign. Now you have outside function, which is ln, and you have inside function. So again, you have to use the chain rule since you have a ln of 5x plus 2. So your function is made of something like inside 5x plus 2. So first of all, the derivative of ln is 1 over. So you want to focus on this outside function, which is ln. So remember that the derivative of ln is 1 over this entire argument. So 5x plus 2 goes on denominator. And we're not done yet, obviously, so you want to take care of the derivative of 5x plus 2. So focus on this inner part, inner component, and you could ignore this ln at this point. So the derivative of 5x plus 2 is going to be just 5. Since the derivative of x is 1, the derivative of 2 is 0. So that gets multiplied by 5. And technically we are done. So all you need to do is just simplify. Make sure you get it in the simplest form conceivable. So equals. So you will get, again, negative 5 goes on top. and your bottom expression remains the same, 5x plus 2. And that's your derivative. Yeah, that's your derivative for this original function. One more ahead. Alright, suppose you have something like this. Looks a little bit intimidating, I know. Let's break it down. First of all, simplify it within laws of logarithms. First of all, you have a ln of something raised to the power. Use power law for logarithms. And again, it says all you do is just bring this power out front. Let's call it p as a coefficient. So this power becomes the coefficient of your logarithm. Here I'm using ln, which is basically a shortcut for log to the base e. It's also true for logarithms to any base, to any number. Now, go ahead and rewrite it as a. So again, this power comes out front as the coefficient. So it becomes 3. So you want to keep ln of x times x plus 1 as your argument. So x plus 1. And at this point, if you look at your argument, basically you have two expressions being multiplied together. And if you might think, you might want to expand it, to open up the parentheses and get rid of this. I wouldn't do this, but what I'm going to do, I'm going to use another law of logarithms, which is basically called a product law. And here's there is a reminder. So if you are given something like ln a times b, so you have argument which is two factors being multiplied. This logarithm can be broken down, can be split up into two logarithms to the same base, obviously, being added together. So it's the same thing as ln of a plus ln of b. So look at this. Your a is basically x, your first factor, your first term. And your b is going to be this entire parenthesis, x plus 1. So I'm going to rewrite this logarithm as a two logs being added by this product property or product law. So also you want to keep this 3 first of all. And it becomes ln of x plus. And you want to put the parentheses, since these 3 gonna be distributed over all terms inside the parentheses. So ln of x plus 1. So for the second log, this entire x plus 1 goes as an argument. So close the parentheses. That's all at this point, and if you like, you can basically distribute these 3, so 3 gets multiplied by both terms inside of this log, but basically we are ready to take the derivative. So this is just the simplest version of your original function. And look at this. It's much easier to handle the derivative of this than if you gonna do it with original one. Now, let's have a look at the derivative. So y prime gets, so you want to keep this 3, and you want to take the derivative of this, what you have inside of the bracket. So again, the derivative of ln is just 1 over x. Go ahead and write it. You want to keep addition. And the derivative of ln of x plus 1 is going to be again 1 over this x plus 1. And technically you have to use the chain rule, since it's not x, it's x plus 1. However, the derivative of x plus 1 is going to be just 1. So basically the chain rule doesn't matter at this point. But it will not hurt to use it in order to get into this habit of using the chain rule, because it's easy to forget. Alright, and technically we are done. So basically you could add these two fractions together by getting the common denominator, and also whatever you get inside, you would multiply by these 3. So let's simplify it down as much as we can. So 3 gets multiplied by, so the common denominator gonna be x times x plus 1, so 2 fractions added together. So on top of your fraction, x plus 1 plus x. And you are left getting 2x plus 1. And also I'm going to place this 3 on top. And your bottom expression remains the same. X plus 1. If you would like, you could definitely expand top and bottom. So for me it's perfectly fine. You could go ahead and write like 6x plus 3 over x squared plus x, or you could leave your bottom without removing the parentheses. All of these ways are fine, either way you like. Completely up to your whim. Anyway, that's gonna be your derivative for that function. Alright, I wanna give you one more. And I wanna show you how to deal when your argument is a fraction. So some expression over another expression, its overall form. You have to simplify it within quotient law of the logarithm. It's not a product law, it's a quotient law. Since inside you have this overall form. Expression is divided by another one. And all it says ln of a over b, it's precisely the same thing as ln of a minus ln of b. So basically this logarithm can be split up into 2 logarithms. So logarithm of top minus subtract off the logarithm ln of bottom b. So before taking the derivative, let's simplify. So equals, so ln of x, so ln of top expression, which is x, minus subtract off ln of bottom expression that happens to be 2x minus 1. So 2x minus 1. So check to see if you can simplify any further, because sometimes also you might have something like power like we did before, and anytime when you run into ln of something raised to the power, so you want to bring this power out front as the coefficient. So keep simplifying as much as you can until you break down your ln into the simplest components that would be much easier and faster to take the derivative of. Now there is nothing that you can do. Carry on with the derivative. So y prime will get. So remember, when you have 2 chunks, 2 functions, and you need to take the derivative of, so you want to take the derivative of the first hunk and you need to take the derivative of the second part. So the derivative of ln, it's gonna be 1 over x, it's just piece of cake. You want to keep the subtraction minus, so the derivative of the second one. So again, it's gonna be 1 over 2x minus 1. And at this point, you have to apply the chain rule, since your ln function is made off of 2x minus 1. So another function is nested into your ln function, which is going to be outside function, and your inside function is 2x minus 1. So you have to keep applying the chain rule. So the derivative of 2x minus 1, it's going to be just 2. So this one gets multiplied by 2. Clean it up. So you want to rewrite the first fraction as is, minus, so 2 goes on top. And be careful, do not cancel this 2 with this 2. They are completely different 2's. And this 2x minus 1, there is no multiplication between, so you cannot cancel this 2. All you could do, you could simply get the common denominator, and this kind of problems they require to just rewrite it as a one single fraction. So it's going to be x, 2x minus 1, the least common denominator, and 2x minus 1 goes on top. you want to subtract 2x. And here's great news, 2x and minus 2x. They're the opposite terms. They're gonna cancel each other out. And you're gonna left with just -1. So you wanna pull -1 in front of your fraction, so 1 stays on top. And your bottom remains the same, it's x, parenthesis 2x minus 1. And if you want to, or if you have to, go ahead and expand this by taking this x and distributing over both terms inside. You can get rid of these parentheses. You can remove them. So I would leave my answer like this. For me, it's totally fine. And that's your derivative for this function. Alright, with this being said, I hope it has been helpful to you. Huge thanks for watching and training your brain. I know everyone hates maths, but if you like my video, please click this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, and turn on this notification bell so you will not miss out my new uploads. Taking the derivatives of these ln functions by you need to know just straight, and if you know, and if I'm using ln, which is basically a short hot. Alright, I hope it has been helpful to you. Huge thanks for watching and training your brain. I know everyone hates maths, but if you like my video, please click.